Imagine you wake up tomorrow morning, and you're on Saturn, not through a telescope, not on a screen, standing inside it. The first thing you notice isn't the light or the cold or the pressure, it's the sound. That's not music, not sound design, it's Saturn. Radio emissions captured by NASA's Cassini spacecraft shifted into a frequency human ears can hear, a planet humming across more than 1 billion kilometers of empty space. The same hum that would greet you the moment you arrived. For a moment, it almost sounds alive. When most people picture Saturn, they imagine beauty, perfect rings, soft golden clouds, a peaceful giant floating quietly beyond Jupiter, calm, almost harmless. But appearances can be dangerously misleading. Behind those rings is a world that tears itself apart, where physics behaves in ways scientists still struggle to explain, where pressure becomes so extreme that matter transforms into something almost unimaginable. After 13 years studying this planet, the Cassini mission didn't solve Saturn's mysteries, it created more. Tonight, we're going beneath the picture you've seen your entire life, to find out why the most beautiful planet in the solar system may also be the most terrifying. From Earth, Saturn's rings look solid, almost like a giant vinyl record wrapped around a planet. That's an illusion. They're made from billions, perhaps trillions, of separate pieces of ice and rock, some smaller than grains of sand, others the size of mountains, each on its own tiny orbit, blurring together into one of the most recognizable sights in the universe. Or at least they used to. Because Saturn is quietly destroying them, not someday, right now. Every second, particles are disappearing. For decades, astronomers assumed the rings were ancient, as old as the solar system, 4.5 billion years. They looked permanent, timeless. Cassini revealed something nobody expected. The rings are far younger than believed, and they're dying. Sunlight, radiation, and microscopic space dust constantly strip electrons from the icy particles, charging them. Once charged, gravity stops being the only force acting on them. Saturn's own magnetic field grabs the particles and pulls them out of orbit, down into the planet's upper atmosphere. Scientists call it ring rain, an endless, invisible shower falling into Saturn every second, all the way around the planet. Cassini detected the chemical fingerprints it leaves behind: water, organic compounds, charged particles raining into the giant planet below. The process isn't balanced. The rings lose more than they gain. Every day they grow slightly thinner, slightly weaker. You won't notice it in your lifetime, but on astronomical timescales, Saturn is erasing its own masterpiece. Some estimates suggest the rings could vanish within another 100 million years. Saturn itself is over 4 billion years old. If that estimate holds, we exist during an almost impossibly brief window, a moment when Saturn still wears the feature that made it famous, like visiting Earth during the age of dinosaurs. Future civilizations, if any exist, might know Saturn only as another plain gas giant. But here's the stranger question. If Saturn can destroy the very thing that made it famous, what else is happening beneath those clouds that we haven't understood? Because hidden at the very top of the planet is a shape that has survived for decades, a shape that shouldn't exist on a world made entirely of gas. Every rotating fluid in nature eventually settles into the same shape. A circle. Spin water in a bucket and it forms a circular vortex. A hurricane over warm ocean organizes into a spiral. Entire galaxies spinning across hundreds of thousands of light years settle into smooth curves. Circles are what rotation produces. It's close to a universal rule. Saturn's North Pole doesn't follow it. Instead of a circle, a hexagon. 6 flat sides, 6 sharp corners, sitting on a world made entirely of moving gas, with nothing solid anywhere to hold that shape in place. We haven't just seen this shape once, we've watched it survive. Voyager 1 photographed it in 1981. Cassini arrived decades later and kept watching. 13 years, thousands of images. Same position, same size, same shape. Weather doesn't behave that way. A hurricane on Earth lasts weeks. Even Jupiter's Great Red Spot has been visibly shrinking for over a century of observation. Saturn's hexagon hasn't lost a single corner in over 40 years of watching, and the deeper Cassini looked, the less this resembled ordinary weather at all. Infrared instruments revealed it isn't a thin pattern on top of the clouds. It's a column, a rotating structure reaching hundreds of kilometers down into the atmosphere. Real depth anchored deep inside the planet. That's what's expected inside a giant planet. Chaotic motion, producing a field that should itself be slightly imperfect, slightly tilted. Earth's field is tilted about 11 degrees. Jupiter's is tilted. Neptune's too. Uranus is badly distorted. Every planet follows that rule. Except Saturn. During Cassini's final orbits, the mission's grand finale, diving repeatedly through the gap between Saturn and its innermost rings, its instruments measured the planet's magnetic field with unprecedented precision. Scientists expected a slight tilt, maybe a degree. They found less than 1/10 of 1 degree. Functionally, none at all. According to our best models, this shouldn't happen. A field generated by chaotic, turbulent fluid should not be able to align itself that precisely, not by accident. Imagine spinning a coin, watching it stay perfectly upright for hours without the slightest wobble. You wouldn't just be surprised, you'd assume something underneath was holding it steady. One leading hypothesis, a stable layer of semi-ionized hydrogen surrounding the metallic core, smoothing the field before it ever reaches the surface. Like frosted glass in front of a flickering light. The chaos stays behind the glass. What emerges looks calm. It's an elegant idea. No one has ever confirmed it. We can't drill into Saturn or send anything into an ocean of metallic hydrogen. Everything we know is built from mathematics, simulation, and brief flybys. We're trying to understand the interior of a world we'll probably never touch. A disappearing ring system, a storm shaped like a perfect hexagon, a magnetic field that refuses to behave like any other. Together, they suggest something larger, that our understanding of giant planets may still be incomplete. Perhaps Saturn isn't breaking the laws of physics. It may simply be exposing the parts of physics we haven't discovered yet. None of these mysteries answer a simpler question. What would actually happen if you went there? Imagine floating above Saturn's cloud tops. For one brief moment, the view is breathtaking, rings stretching across hundreds of thousands of kilometers, sunlight glittering off billions of icy fragments. Then gravity takes over. You begin to fall. At first, nothing feels unusual. The upper atmosphere is thin, no surface rushing up to meet you, only layer after layer of pale golden cloud. As you descend, the winds rise. 200 kilometers per hour, 500, 1,000. In places, Saturn's jet streams exceed 1,800 kilometers per hour, among the fastest sustained winds in the solar system. On Earth, that would erase cities. On Saturn, it's just weather. The deeper you fall, the darker it gets. Sunlight fades, ammonia clouds give way to denser layers rich in water and other compounds. Breathing becomes impossible. Communication becomes impossible, and the pressure keeps climbing. Metal bends, instruments fail. Temperature climbs from freezing to hundreds of degrees, then thousands. Eventually, your spacecraft is crushed, not because it hit anything, but because the atmosphere itself became stronger than the machine built to survive it. No safe landing, no hidden continent, only an endless descent into a world that slowly destroys anything that enters it. Add Saturn's radiation belts trapping high-energy particles, less extreme than Jupiter's, but powerful enough to threaten spacecraft electronics over time. And every mission here has to account for a planet actively working against it. Which brings us back to Cassini. After a 7-year journey, Cassini spent 13 extraordinary years exploring Saturn and its moons, discovering geysers erupting from Enceladus, methane lakes on Titan, mapping the rings in extraordinary detail. Eventually, it ran low on fuel. NASA faced a choice: leave it drifting or end the mission deliberately. Destroying a working spacecraft sounds wasteful, but 2 of Saturn's moons, Enceladus and Titan, are among the most promising places in the solar system to search for conditions that could support life. Enceladus hides a global ocean beneath its ice. Titan has rivers, lakes, and complex organic chemistry. If Cassini were abandoned, its orbit could eventually destabilize and, decades or centuries later, crash into one of those moons, carrying dormant microbes from Earth into a place we desperately want to study untouched. So on September the 15th, 2017, Cassini turned towards Saturn one final time. It entered the atmosphere at incredible speed. The pressure tore it apart. Its instruments fell silent. Within moments, everything humanity built for that mission became part of Saturn itself. Even in death, Cassini kept protecting the discoveries still waiting to be made. Saturn is still keeping its biggest secrets. Play that sound again. The same hum that greeted you the moment you imagined standing on Saturn, still traveling outward, right now, in every direction. When we first looked at Saturn through a telescope, we saw beauty. Perfect rings, gentle colors, a symbol of balance. The farther we traveled, the more that illusion fell apart. A planet quietly losing its rings, a storm shaped with impossible precision, an interior where hydrogen becomes metal, a magnetic field that refuses the rules every other planet follows. Perhaps that's what makes Saturn unsettling, not because it's trying to destroy us, but because it reminds us how small our understanding still is. For centuries, we believed the universe grew less mysterious as science advanced. Saturn tells a different story. Every answer opens another question. Maybe the scariest thing about Saturn isn't the storms or the pressure or the mysteries hidden beneath its clouds. Maybe it's the realization that one of the most familiar objects in our night sky is still capable of surprising us. If a planet we've studied for generations can still challenge the foundations of planetary science, what else is waiting in the thousands of worlds we've barely begun to explore? The universe isn't running out of mysteries. We're only just beginning to find them. This is NOVADREAD, and out there, another mystery is already waiting. I'll see you in the next one.